Hello friends, myself V. Volkar, Assistant Professor, Science of Technology, Jacobin. Today in this video, I am going to discuss about Jacobin of Implicit function. So in my previous video, I have discussed about Jacobin of composite function. So let us consider the function f1 of uv x comma y and f2 of uv x comma y. That is, here I am taking two functions of variable uvi xy. So let f1 of uv x comma y equal to 0 and f2 of uv x comma y equal to 0. Then if I want to find this u and v, derivative of u and v with respect to x and y, the formula is like this: minus 1 square derivative of this f1 and f2 with respect to xy. Derivative of f1 and f2 with respect to x and y divided by again derivative of f1 and f2 with respect to u and v. Similarly, if I consider three functions in 6 variables, f1 of uvw, xyz equal to 0, f2 of uvw xyz equal to 0, f3 of uvw xyz equal to 0, then differentiation of uvw with respect to xyz, that is dou of uvw with respect to xyz. Here three dependent variables are there and three independent variables are there. Therefore, here I am getting here minus 1 cube. Here there are two dependent variables and two independent variables. That's why here I am having minus 1 square. So this implies again differentiating f1, f2 and f3 with respect to this xyz and f1, f2 and f3 with respect to uvw. So this is the formula of implicit function. So let us see one example. If x plus y plus z is equal to u, y plus z is equal to u into v and z is equal to uvw, then find dou of x y z with respect to dou of uvw. Solution. So let us consider, let f1 is equal to x plus y plus z minus u is equal to 0. So I will take all the terms on one side and I will take this one as function 1. f2 is equal to y plus z minus u into v is equal to 0 and f3 is equal to z minus uvw. So see here the question is we have to differentiate x, y, z with respect to u, v and w. So what it means here, x, y, z are dependent variable and u, v, w are independent variable. So if I want to differentiate this x with respect to u, obviously v and w becomes constant. If I see the given equation here, x plus y plus z is equal to u, here additional two dependent variable I am having in this equation, therefore this is implicit function. So it is difficult to differentiate like that. Otherwise what I have to do, I have to convert this complete x in terms of uvw, y in terms of uvw and z in terms of uvw. Then I can go for the direct differentiation method. So instead of that, I am using here implicit function method. So first I will write the formula here. So our question is here, dou of x, y, z with respect to dou of uvw. So here there are three dependent variables and three independent variables. So this becomes minus 1 cube differentiation of F1, F2 and F3 with respect to UVW. UVW whole divided by again differentiating F1, F2 and F3 with respect to X, Y, Z. With respect to X, Y, Z. So this implies dou of X, Y, Z upon dou of UVW is equal to minus 1 to be nothing but minus 1. So I will write the determinant of this one, that is the definition of, I will apply the definition of Jacobian. So this implies numerator dou of F1 upon differentiating F1 with respect to U, dou of F2 upon dou of V, sorry, dou of F1 upon dou of V and dou of F1 upon dou of W. Similarly, differentiating F2 with respect to UVW, that is dou of F2 with respect to U, dou of F2 with respect to V and dou of F2 with respect to W. Last one is F3 with respect to UVW. Dou of F3 with respect to U, dou of F3 with respect to V, dou of F3 with respect to W. Whole divided by, so right here, whole divided by F1 with respect to X, with respect to Y, with respect to Z. That is dou of F1 with respect to X, dou of F1 with respect to Y, dou of F1 with respect to Z. Similarly, F2 with respect to X, Y, Z. F2 with respect to X, F2 with respect to Y, F2 with respect to Z. And the last one is F3 with respect to X, F3 with respect to Y, F3 with respect to Z. So here, while differentiating this F1 with respect to U, in case of implicit function, other than U, the remaining terms become constant. So that is, derivative of constant is 0. Again, when differentiating F1 with respect to V, other than this V, all the remaining terms become constant. So I will simplify this one. Therefore, dou of X, Y, Z upon dou of UVW is equal to minus. So now, differentiating F1 with respect to U. Derivative of F1 with respect to U, X is constant, derivative of X is 0, Y is 0, Z is 0, derivative of minus U is minus 1. F1 with respect to V, X, Y, Z and U becomes constant, here there is no V term, so therefore derivative of this one is 0. F1 with respect to W, here again we are not having W, so again derivative of this equation is 0. Then F2 with respect to U. Differentiating F2 with respect to U, Y is constant 0, Z is 0, U and V with respect to U, V is constant, derivative of U is 1, so remaining is minus V. F2 with respect to V, so this one is and this one is become 0, so this becomes minus V. F2 with respect to W, again here we are not having W term, so this is what? 0. F3 with respect to U, derivative of Z is 0. UVW with respect to U is minus V into W. F3 with respect to V, Z is again 0. Here U and W are constant, derivative of U is 1. That is minus UV. So the last one is F3 with respect to W. So this is what? Minus, sorry, here it is U and W, and last one is minus U and V. So derivative of f3 with respect to v is 1 minus ui w, and this one is minus ui. So divided by. So now I will differentiate f1 with respect to x. Other than x, remaining terms become constant. So derivative of f1 with respect to x is 1. So these other terms become 0. Remaining is 1. f1 with respect to y, x0, z0, u0. Derivative of y is 1. f1 with respect to z, again x0, y0, u0. So derivative of z is 1. f2 with respect to x, here f2. Here no x term, derivative of this one is 0. f2 with respect to y, derivative of y is 1, z and u are 0. f2 with respect to z, so again this is what? 1. So last one, f3 with respect to x, there is no x term in x3, sorry f3, therefore derivative of that one is 0. f3 with respect to y, 0, and f3 with respect to z is what? 1. The derivative of f3, that is z with respect to z is 1. So I will simplify this one. So therefore this is minus. So I will simplify the numerator. I will simplify the determinant. Minus 1 into, so multiplication is minus to minus become plus u square v minus, this is what? 0. Minus 0 into anything is 0, and that one plus 0 into anything is 0. So I go for denominator. 1 into, so 1 into 1 is 1 minus 0, minus 1 into, so I will read first row, middle column, 0 into 1 is 0 and 0 into 1 is 0, that is 0 minus 0, plus 1 into, again this is what? 0. So therefore dou of x, y, z with respect to dou of u, v, w is equal to minus, so this is minus u square v upon, so this one is 0, 0 into anything is 0 and this one becomes 0, so remaining is here 1. So this implies u square of v. So this is our required answer. So here by using the concept of implicit function, we can differentiate any type of function in case of Jacobin. Thank you.